we're going to move on to Scott Smith. He is the founder and CEO of AquaFlex Holdings. He specializes in developing and commercializing technologies to detect and remove contaminants such as oil, metals, and bacteria from water. The company's goal is to test and prove its cutting-edge technologies in real-world conditions. And today he's going to be speaking about his open-cell polyolefin sorbent foams and applications and results of tests conducted at Ohmsett. So Scott, we're ready for you.
I'm ready. So where the share screen, I don't see it.
It's down at the bottom of your Zoom screen.
There we go. Okay, well, thank you for allowing me to present today. I want to start out by saying I can't compliment BSEE enough and Ohmsett. We've been there twice in 2014 and recently, and you're going to see the first public results that I'm presenting publicly today on the new recommended Ohmsett protocol to reflect more real world conditions. And I am going to go very rapidly. I am going to cover 11 years in 20 minutes. And I want to leave time for questions. And also I want to say that, you know, BSEE, with that study, they spun it on sorbents. Again, I can't credit the vision they have. And when I saw that they were working on new standards to reflect oil and water together in real world conditions, that's, you know, that's great to see coming from our government and them funding studies. I'm going to go through history very quickly. This is designed for people that are interested so they can actually see my laboratory, which is the real world, where we were proven in the history. We were endorsed by BP. We were on the cover of USA Today. This is pretty clear about the oil, the open cell foam being absorbed and versus some of the white pads that were in the Gulf. And what came out in the real world was we were far lighter. Foam, open cell foam was 1.7 pounds per cubic foot. The white polypropylene single-use sorbents are about 57 pounds per cubic foot. And that's just another view. Those are actual pictures from BP. I was on the ground deploying in the Gulf. BP issued at the time an endorsement, part of an alternative response technology, also funded with the American Petroleum Institute. And Michael Cortez, I think he's retired now, in the Journal of Petroleum Technology. You can see the yellow arrow. The foam was OpFlex at the time. It became AquaFlex in 2016. And then I'll be talking about, you know, the new roles that are AquaPal here shortly. The alternative response technology in the APA study, they had 120,000 submissions, and 40, I believe, 40 or 43 were approved and actually used and recommended. And then from the Coast Guard, Captain Frank Paskowich, in his expert report in BP litigation, basically testified, because BP was getting accused of not, you know, promoting or doing everything they could with new technologies. And BP had a great vision back then in dealing with them. And I can't compliment them enough how supportive they were in new technologies. The open cell foam was one of 40, all 40 great technologies. That's 0.1% of the ideas in the Gulf of Mexico were proven, validated, endorsed by BP, and recommended to the Oil Spill Response Organization. So I'm pretty proud that my technology was part of the 0.1% that were actually approved in the Gulf. This is a slide. On the left, you're looking at the open cell foam at a commercial laundry. Actually, this was after the BP USA Today article. I started getting contacted by commercial laundromats. I'll be talking more about that in a second. On the right is actually from 2014, we went to Ohmsett, and you're going to see some short video clips here. And we did some water column testing where we submerged in a cage. I have detailed reports from Ohmsett, and anybody that's interested, I'm happy to make those available if you want to email me after this presentation. And here is the commercial laundromat in Pennsylvania. They were being fined by the EPA, and we came up with the concept of a filter bag. Now they started, went from getting fined to reusing this, wringing it out and selling the waste oil either for heat or motor oil. And what before this, the grease was, an oil was 1,120 parts per million, and went down to 46 with the filter bag. So this is everyday oil spills. And this led into some other applications. I really didn't know until we started developing this business, biological oxygen demand or suspended solids, that we were able to reduce that. And they had it tested by their outside lab because they had to report it to the EPA. So 96% oil reduction. And then this ultimately led to this same technology being approved, used, and validated to clean up toxic algae and some other applications, which we'll get to. Yeah. So what you've seen in the past, for those of you that know about this technology, it was AquaFlex in 2010 and AquaFlex in 2016, the trademark. And this is a 6-step block or bun operation. It's a batch process. And you see here the 5 steps, and then there's the 6th step. And now to the open cell. The open cell polyolefin foam is produced in 1 step in roll form and 3/8. Ultimately, deploying these rolls, we've had, I live in Massachusetts, and we've had harbor masters, that some remote oil spills, talking about booms made out of this product. Rolls are so much lighter than the single-use polypropylene sorbents, that they really like that because of the ease of deployment, and it's easy for the laborers. And we can customize this basically to any configuration. And I want to talk about this a little bit. Dave Kennard, formerly of BP, I'm sure a lot of you know him. In the Gulf of Mexico, I learned about the he said status quo of inaction is no longer sustainable. And I've been on the ground in about 60 different oil spill, disaster, chemical spill events. And these are just some sample pictures of single-use white plastics going to the landfill. They're not oiled. And again, this is all about us working together and having professional conversations, and sustainability is a real issue. And I think when BP endorsed this technology in the Gulf, they really were way ahead of their time on sustainability, wringing out and reusing it. BP was I got to really compliment them. They were well aware of the issues with not getting the oil. You can maybe get the oil out of the water much more quickly, and reusability. And this is actually pictures from Ohmsett in 2014. And we're going to get to a video in a second. So you can see the tank testing. And I know I thought Amy's presentation was fantastic. And I have the data. You can see how the oil wringing out of this. So I know I would love to be able to speak to the OSROs that gave the feedback about the re-oiling in the water. We were out at the outdoor tank in Ohmsett, and we have all that data from 2014. This is a short clip, and these are all YouTube links of Freeport McMoran mines in an automated system using the material, the open cell foam material in 2013 in an oil recovery system. And that has been, also, just this morning, it's not in the presentation. We have a customer in British Columbia in Western Canada that NCS Fluid Systems. And I was told that they've now executed a joint venture with First Nations, which is the indigenous peoples. And they now have contracts to move forward with the LNG facility there and also the mining facility. So we're really excited about this vision that started 10 years ago, seeing it come to fruition and being able to work with everybody and all stakeholders, not just for sustainability, but actually to get the oil out of the water more efficiently and more quickly. And here, this is back in Ohmsett in 2014. And we made this from block foams back then. You can see this patched together. We now have the ability to make this in continuous roll form. And the continuous roll form is significantly more cost effective, which is good. And this is Ohmsett from 2014. We wanted to duplicate real world conditions. And this was a prototype, eelgrass, what we call our open cell eelgrass boom system. And we had them duplicate real world conditions and how the oil can go over the regular booms. And we've designed this open cell foam where it can be connected to orange containment booms, even the white booms. again, I think I can't emphasize enough that Ohmsett brings something unique that's not capable anywhere else in the world. And that is the ability to test in real world conditions. And I also want to say, we plan to go back there in a very big way to Ohmsett in 2022, or maybe even later this year, and consider this an open invitation for anyone participating, anyone from the government, suggestions, things you'd like to be tested independently under any test procedures and in the big tank. We're all ears, and we would love to work with anybody that's interested and invite them to the testing. And I also have been, to 60 different contamination events and filed patents. And what I do is I've gone into the disasters and then validated it with third-party lab testing, and this in the public domain. Anybody interested can go into Google Patents and take a look at it. And in 2018, a competitor from the closed cell business and I came together. Company's called Palza. They're based in Israel. They're well aware of what's going on with that oil spill. A great joint venture partner. They have global manufacturing facilities everywhere. We manufacture in North Carolina here, and we adapted together to take the technology and scale it up in a big way. And that's when we went forward. In 2019, we went back to Ohmsett and we did the ASTM testing along with their new recommended protocol. And at the end of this, I'm going to get into some other applications like the toxic algae. And I never thought I'd be saying this. This material, same open cell material, has been quickly adopted and proven effective in COVID-19 mitigation, believe it or not, and even used in face masks. And on this slide, you can go to the links to the websites for more information. Now, the open cell foam, we tested at Ohmsett at 2019. It's 112 square feet of surface area per square foot of foam. That's what it's all about when you're trying to get oil out of water. The functionality, very hydrophobic. That's become very important in some COVID mitigation applications that we have. We maintain buoyancy at full oil saturation. We don't sink. And I brought this up before: lightweight to low density, ease of deployment, and quick scalability. This has been proven over and over again in real world with real customers. At an Ohmsett, we did the ASTM F726 testing for 15 minutes and 24 hours. The open cell foam maintained its buoyancy. We tested with some representative white polypropylene single-use fiber sorbents and also some single-use polyurethane foams. The polypropylene ultimately sunk. And again, this is pure oil. This is a lab test, not necessarily reflective of but it's still very helpful. And we looked at the multiple absorbed oil weight, and I'm going to go quickly through these slides because all this data can be available separately. We were around 28 times the weight absorbed, and the white polypropylene single-use plastic was around 8. When I first saw this, I well, that's not really that big a deal because we're so much less in weight. And then we were 30 times at 24-hour weight, and the white sorbent was 8.9. The polyurethane was 4.5. But this is what really I was kind of surprised in a good way here, is that we then calculated the gallons of oil absorbed per square foot, and that's 0.23, where the white polypropylene was 0.09. Now, I know there's issues over sustainability and cost may come up, but if you want to get, even if you use the open cell foam AquaPal in a single use, you're going to get the oil out of the water more quickly. And if you send it to a landfill, we've also done the independent testing for biodegradability, ASTM D5526, and there's an additive in where it will biodegrade in a landfill. We can also the commitment working towards sustainability. And this is the 24-hour test. We did that also, where 0.25 gallons per square foot versus 0.1. And we took the grams of oil absorbed after 15 minutes and 24 hours according to ASTM F726, and we compared 15 minutes and 24 hours. And there you can see the performance speaks for itself. And Ohmsett field scale test, the field scale test protocol, I can't say enough about Grant Coolbaugh, Ellen Canone, available after hours, and I cannot recommend Ohmsett enough. I would love to see regulations that you got to get certified at Ohmsett, and I'm all for the best technology proven at Ohmsett. And again, credit BSEE with the vision and the funding that they have done separately for this field scale test protocol. This kind of speaks for itself. This is from the Ohmsett executive summary report. It talks about the necessity for a test that featuring environmental factors representative of field use conditions. And this is interesting that now that I'll get to why I was personally affected by COVID. I've been reaching out to ASTM. Just like ASTM testing is helpful, it doesn't always reflect the real world, like this face masks or non-medical masks. Mannequins without hands that don't move, that don't touch their face. That's just one thing. But, and also these nanofiber masks, no one's talking about potential inhalation of lungs and all that other stuff. So this is just the importance of working together, whether it's face mask tested for COVID-19, whether it's algae testing or oil, to duplicate how things are used in the real world. This is the field scale test that we actually did at Ohmsett, filmed as we did it. You can see how hydrophobic the material is with the oil being, with the water being repelled. And this was all measured. And this is we did it static, the water with the oil and water mixed, and then we did mix energy. And this is both the white polypropylene single-use sorbent and the Open-Cell roll material in foam pad versions showed a 15 to 30% drop off in the ratios in the oil absorbed. So this goes to the point that you need to really duplicate real world conditions and then calculate. But you can see here, even if you use this Open-Cell foam, one use, what are the other costs to the environment of not getting the oil out of the water? And what are the other costs to the environment by all the trips to the landfill and the total carbon footprint? And again, I think it's great, the study that BSEE funded with Amy McClellan. I would love to see BSEE fund future studies for the total cost impact of sorbents and how they're used in the real world. I'm going to go quickly here, algae media coverage. We've also been adapted to be used in algae, and again, real world data. This is right here on Cape Cod. I never in a million years imagined this technology would be useful in algae remediation, but I got a call from Bermuda and scientists on Nantucket. I said, I don't know, and we put it to use. And this is and then we used mesocosms on Cape Cod with the University of New Hampshire Freshwater Biology Lab, a third-party study.
There is some proving technology that can help remove toxic algae, and we just found out it's going to be used in Southwest Florida in the next few months. I'm Patrick Nolan.
And I'm Jane Monreal. So could this be the solution to our area's algae problem? Fox 4's Jillian Hartman looks into who invented the product.
It's made of a foamed polymer that at the molecular level attracts oil like a magnet and repels clear water.
So I'm going to go quick. Here's backup studies where you can link in. And here's another patent filing. And I have 2 minutes left. I didn't know when I filed this patent, infusing Open-Cell foam would play out in the COVID world with biocide, but we got notice that this patent's actually issuing. In 2002, the material was approved by the FDA for the US military, all because we're non-polar and we don't deactivate disinfectant. And I'm going very rapidly here, but the concept of infusing AquaFlex Open-Cell foam to mitigate or neutralize exposure to chemicals is not new. And so 18 years later, I didn't know how personal this would become to me. My daughter, frontline worker at a nursing home, contracted COVID, wearing full PPE gear, N95, 25 residents died. She's the social services director. In the pain and agony I heard about from her, families that couldn't be with their loved ones, dying alone. I went on a mission, a big time, and my daughter still suffers from some lung issues. Frontline workers wearing this gear are getting infected everywhere. So I went on, I couldn't believe it. Paper towels, cotton rags, deactivate disinfectant. It's called quat binding. There's more information. I even talked to the Australian National Science Agency, CSRO, and indeed, the virus does last on surfaces up to 28 days, and you got to look at temperatures. So there's a lot of data out that, and you're going to read more about this. And then in my own, I reached out to Kimberly Clark, and then this is my own kitchen, proving how cotton rags deactivate disinfectant and the open cell foam works. And then I posted on LinkedIn, and then somebody reached out to me, and I have a great partner now with Biofoam. Also do work with a union, and at bottom line, it's simple. You can't remove oil from water if you don't make contact with the oil. You can't kill pathogens if you don't make contact with the pathogens, and the disinfectant is deactivated. It's all about increasing surface area. There is a link to the playlist of all, all the videos in this, including the one wasn't shown about the work where I'm working with nationally with the United Association of Plumbers and Pipe Fitters and Legionella. And that is my daughter, and we just introduced a mask with more surface area. And we're doing everything we can to help people. And on COVID, anybody on this conference, email here. We're offering 10% discounts to anybody in the conference, and 20% if you're a government official. And I'm just dedicating this to all the frontline workers because I've seen the pain and agony firsthand and what's going on. Thank you.
Thanks, Scott. You came in as promised in your allotted time, and I know that was a lot of information to share. You went through it pretty efficiently, and I think we have some questions for you, Lindsay.
Yes, there are a couple questions from Mitch Malden. Given the endorsements from BP and API and proven efficacy, how have the oil spill response organizations responded to your technology?
Well, that is that's a very good question. That's a compliment, and that's a complicated question. And in fairness to the oil spill or response organizations, going sustainable and reusing this material could really affect them economically. And I don't know, maybe the next study with BSEE and maybe a follow-up with Amy McClellan is to focus on the cost of the landfills and the cost of not getting the oil out. Maybe the economic incentives for the OSRO should be more on how quickly they clean up the oil spill and how fast they get the oil out. That's just from my experience. I'm really excited because our first big breakthrough is now in Canada, believe it or not. But again, I'm all ears. We want to work with everybody with a professional, collaborative way. And I'd love to be contacted by an OSRO to start immediate work together and go to back to Ohmsett with the OSRO.
Great. And also from Mitch Malden, have you seen more emphasis on efficiency or reusability and sustainability since your initial work in BP?
A good question. We've seen emphasis in all other factors, like, for example, in the algae market, we go to a waste to energy facility. You're not moving toxic, algae and their toxins. And we've worked we've got permission from the Florida EPA, and we're actually, it's all about sustainable, low carbon footprint. And it's the sorbent oil spill industry that really hasn't adopted anything on a large scale in 30 years. But I'm optimistic. I think that day's coming, and we're here to embrace it and support anybody that wants to work with us.
And one more question. During Deepwater Horizon, heavily oiled snare and pom-pom booms became very heavy and hard for workers to safely lift aboard vessels. If your foam is light when deployed but heavy when oil is retrieved, can there be a systems approach where it's winched aboard and go directly to a ringer? And whether or not the oil is safe for reuse, could it be provided for better worker safety during handling?
That's a great question, and I really appreciate that. And they started calling it the green stuff in the Gulf because those Tyvek suits, I was out there in the 100-degree heat. It not only absorbed more oil, it didn't absorb any water. That has to do with the polymer it's made of. And I guess OSHA has a limit, I think 50 pounds, but it was much easier for the workers, especially in the heat, be on their backs and everything. So the answer is yes, and we're adapting to more automated ways. And that's when we go back to Ohmsett, we're going to be, figuring out what are the most efficient ways and getting input from people that do the work.
That's all we have. Thanks.